Hello, everybody. This is Srikanth, Delta Junior College, Hyderabad. Today, let us understand the structure and function of the most important learning component of IIT-JEE preparation. What is the most important factor which makes a student succeed in IIT-JEE exam? What do you do when you go to the IIT-JEE advanced exam? You will be sitting there in the exam hall for 6 hours, 3 hours in the morning and 3 hours in the evening. What do you do during these 3 hours, 3 plus 3, 6 hours? You practically solve problems in maths, physics, and chemistry. These problems which you will solve there are not the problems you solve during your exam preparation. Of course, they are based on your syllabus. They are based on the principles you learned. They are similar to the problems you've done previously, but remember, they are newly framed problems. In the history of IIT-JEE entrance, never the same questions gets repeated. So while you keep preparing for the IIT-JEE exam, how do you go about this problem solving? What is the structure and function? What are the structure and function of problem solving? Being a physics teacher, I'll focus upon problem solving in physics. We'll try to understand the nitty-gritty of this physics problem solving. We'll try to understand the finer details, the specific important details of this problem solving. What is a physics problem basically? Remember, 90% of the times, or I can say even 95% of the times, these problems you get are basically the experiments in physics you would never do. Of course, I cannot call them thought experiments because thought experiments are basically, you will never do even in a lab. You think of an experiment. Einstein made famous these thought experiments. But here, this experiment you could have done in lab, but you don't do here. The subjective problems which you call generally, they are given at the end of a good textbook, or you've got, say, for example, problems in general physics by I.E. Irodov. So these physics problems are basically an experiments which could have been performed in a lab under certain conditions. Remember, even in a problem, there'll be conditions attached. There'll be naturally, because laws of physics are valid under certain conditions, even the experiments have to be done under certain conditions, or the problems have to be framed giving those conditions to you. A problem which do not suggest the conditions there is not a problem at all, not a well-framed problem at all. So yes, the physics problems you do are basically the experiments you don't perform, but think of performing. All right. Maybe, for example, a car is moving with an acceleration, and somehow say the driver could maintain a constant acceleration, and you placed one jar of water, one trough of water inside it. So the surface of water will be inclined in equilibrium inside the car. If you watch and see, that surface will be forming an inclined surface. So what angle does it make with the horizontal may be a question. And by applying some laws of physics without even doing experiments, we don't go and put that trough in the car and accelerate it. We can as well do it, try to understand. It's not so difficult to do. In fact, as a teacher, I would love to show something like that to make physics look interesting. But here, let me come back. Yes. So that experiments were not done, but by applying the laws of physics, you got an answer like tan theta is a by g. G is known. The theta practically could measure. So if A was given in your problem and G is already known, you'll guess that the tan theta is A by G. And if A equals, for example, some 5 meters per second square, tan theta equals half, you will get it's around 27 degrees or whatever. You will get the answer here. And perform the experiment with that acceleration, you will find that angle to be 27 degrees. Tan inverse half may be around 27 degrees or so. So this is a physics problem, basically. But as I told you, we don't do the experiment, we have to solve it here. So the first step is you have to read the problem and imagine that experiment in your mind. Visualize that experiment in your mind. You should be thinking of the car moving and some container being placed, the water becoming slanting like this. All this should come to your mind. But wait. To visualize this, you should understand it. No? So you should read it first, read it thoroughly, properly. You should read thoroughly doesn't mean I want to take a very long time for that. Reading should have become a habit for us by the time you passed out of 10th class. Isn't it? Reading is very, very important. Okay, now let me not go for discussion of reading here. But yes, you have to read carefully. Your English comprehension must be good. You should be able to understand the sentence formation properly. See, I told you all, I'll go for the finer details of the problem solving. So many a time I see students not reading the problem completely because they're not habituated to reading. So while you're preparing for your JEE entrance exam throughout your 11th and 12th class, you should also try to cultivate or improve your reading capacity, reading capabilities. You can read some storybooks as well. If reading a textbook becomes somewhat troublesome, somebody can read a storybook to improve reading. In fact, you can do that whenever you get bored with your regular work. All right, let me come back. Yes. You read it carefully, and as you keep reading it, you will be visualizing that whole physical drama, that whole physical event should be coming in front of your mind. Then look, what does a problem expect? Some answer, some number. It could be a number or it could be an algebraic expression as the answer there. If numbers are not given in the question, some algebra letters are given, finally the answer will be in terms of that algebraic letters only. So you should, the next thing is the data recognition, I'll say. That is, what are the numbers given to you? What are the values given to you there, the problem? And what is that is expected from you? The mind should automatically grab this whole scheme of things. Like as you keep reading, as you keep visualizing that physical event which is happening, supposedly happening there, or the experiment which you would perform, you should also connect the numbers with that experiment. That's where the physics problem solving requires what you call a multitasking kind of a brain. A mathematics problem, you see, once that problem is there, you'll only logically keep connecting. The moment you know how to start it, rest is a little easier. Maybe manipulations may be taking lengthy in a mathematics problem for which you should have looked for an elegant solution. But in physics, the issue is this: most of the time, children have problem here. You need to read. As you read, you need to visualize the experiment on one side of the brain, and then also look for that data there. All right. So once that step of recognizing the data is over. Of course, I don't want you to keep writing all those things actually. In the beginning, you might practice this way, but you need to keep doing things mostly mentally. Otherwise, time will be an issue. In an exam, you have to finish a problem in a given time. So, of course, if you practice it from the beginning, though in the beginning you may write, but consciously you try to visualize things and reduce the number of steps, that also becomes a habit. You need to train your mind. You need to train your brain for that. Okay, right. That data is recognized. Recognizing data means what? Ultimately, the data corresponds to the values of the physical quantities given there. Isn't it so? So what physical quantities are given, what kind of values are given, and what physical quantities value you were asked. After all, physics is about measurement, and the measurable quantities are the physical quantities like force, velocity, acceleration, magnetic field strength, quantum, when the principal quantum number for an orbit, or the frequency of a photon emitted, or wavelength of the light used. So these are all the physical quantities. So the data in a physics problem consists of these values for the physical quantities. Sometimes the numbers may be given, or sometimes the symbols lambda, b, e, m, these things may be given. Right. Now, once those data points are taken, data values are taken, and once you decided what is that you would like to find out, you need to decide which basic principles of physics you know. I don't want to use the word formula, though the principles are all actually in the form of formulas. So, no, my point is this. The basic principles of physics means in your mind, it may not be F equals ma directly. It is, I need to find with the force which is mass into acceleration. You might, the force acting, net force acting in a body, the product of mass and acceleration is also a kind of what you call statement, which actually signifies a wide variety of general things as far as the motion of a body is concerned. So the physics principles in the form of the formulas have to be coming into the mind. And luckily, in physics, there are not many principles, main principles of physics. So in grabbing these main principles, in recognizing the principles required for the problem, the first stage of it is the main principles. Say, for example, in gravity, when you do problems on gravitation, you already know that mechanical energy is conserved. Mechanical energy is conserved is a principle. The mathematical formulation is U plus K is constant. Angular momentum is conserved. L1 equals L2 equals L3 equals L4 at many places in the orbit, for example. The force is inverse square law force, F equals G(M1 M2 by R squared). So this kind of a wording, the meaning, and as well the mathematical formulation are not many. They are actually very small in physics. F equals ma, torque equals a alpha, the idea of reference frame, conservation, four conservation laws like momentum conservation, angular momentum conservation, energy conservation, charge conservation. So some conservation laws, some Newton's second law for translation and rotation, and then the idea of reference frame. It's very, very important to recognize in which reference frame are you going to work out the problem. So this small what you call engine of the physics principles is common for all the problems. Try to understand. But specific to that problem, specific to that area of physics, there are other basic principles like Benel's principle. Though it's a conservation law, you call it Benel's principle, and the formulation, the algebraic expression is different, for example, or Faraday's law of electromagnetic induction, or Ampere's law. All right. So the main universal laws of physics, like I told you, and then specific experimental laws related to that particular topic and particular problem, you should be able to remember. Recollect, I mean. So the mind should connect those particular number of formulations related to that particular problem. Then you need to connect it. The connecting is actually a little challenging thing. Because while connecting, there will be few physical quantities in the laws you've taken, and all those physical quantities are not given there. So you need to assume few things on your own. Remember, the assumed things should go out, will go away, should go away later. They should not appear in your answer. And should be in terms of the data given to you, not in terms of what you thought. So when you brought those equations here, whatever number of physical quantities are there in your problem are not there in the equations. They are more, actually speaking. So you'll imagine few things. And remembering that I'm going to eliminate them later. All right. So yeah, look at this. Laws of physics are finally equalities, equations. Something is equal to something. And you know, ultimately problem solving involves writing few equations there. Right? And the few equations are written from the laws of physics. The universal laws, which will shape, which will decide as to what to do, and then the specific laws related to that, or some manipulated results, standard results you might use. There's nothing that you'll all the time go for the top one. So all these things put together will give you some equations. But you will look at the equations again and see there'll be more unknowns and less number of equations. So you should think of one or two more equations to make the set of equations complete for the number of variables involved. And rest is, of course, manipulation. Rest is, of course, manipulation, I told, but that's also one very important component. People say practice, practice, practice like that, but it actually, I should call it deliberate practice. If manipulation was your trouble previously, you should focus on manipulation for a while. That's called deliberate practice. Anyway, so manipulation, of course, remember, physics manipulation in IIT-JEE is not so difficult because you are supposed to be good in mathematics there. So once your mathematics is good, the manipulation part is not that big. So that manipulation you do, solve the equations and get your answer. So that is what you mean by the structure and function or the nitty-gritty of the problem solving in physics. But it's not over yet. You got the answer. In the exam scenario, of course, that answer you may find in among 1, 2, 3, 4. Or you might fill in a blank, or you might match in a matrix matching. Okay. Or you might write the answer like a numerical. That's okay. But what I mean to say is, when you keep doing this, when you finish your problems in a class, for example, you need to check the reasonableness of the answer. That should become a habit. Even in an exam also, before you jump onto a particular option in the ABCD multiple choice, the brain should just get habituated to look at the reasonableness of the answer. Reasonableness can be checked in various ways. If it is the problem in general terms, like in terms of algebra letters, we should check the dimensional adequacy of the answer. I hope you understand it. The answer is for wavelength, and the dimensions in the mathematical answer you got is of something else. The answer is not going to be right. Right? Even if it's a numerical answer, sometimes it looks too big, sometimes it looks too small, sometimes it looks funny. Like, say, some wavelength of light comes as some wavelength of some, known ultraviolet light comes as some big kilometers. You should know it's not going to be right. So the units, the numbers, reasonableness, and the general answers, dimensional adequacy. And there are so many things like this. As you keep doing physics problems, you develop a lot of intuitive feel for the numbers and the answers and the ideas. So what I was trying to tell you was just take a look, what you call a look in a very short time. Of course, mind should be, I mean, what you call trained like that. You look at an answer, you know it is right or wrong. For teachers, for us, it happens many times. You see, as you keep teaching, you do so many thousands of problems. And teachers, I mean, especially who teach this day and in and out for years, they wouldn't want to mug up answers for a simple reason that if you mug up the answer or solution, the freshness goes in a problem in a class. You need to keep solving problem as if it is happening then and there itself. Not that even the teacher gets bored if he mugs up solution, believe me. But as you keep doing, you develop a kind of an intuition. When you look at an answer, you know it is right or it's wrong. Maybe you don't recognize the right answer, but you'll know it is wrong. But the moment the right answer presented, you say, this is the right answer. So this kind of mood you should be in doing in recognizing the correctness of a solution. So of course, this doesn't come just like that. In 2 years of preparation, if one day you could say that, yes, I got my first problem today, my first own solution today, or I could get the first step for myself today, isn't it? Many times what happens is teachers give the first step and students keep doing it, but they forget conveniently that the first step was given by teacher. And the most difficult aspect of physics problem solving is to get the first step, to get the idea. I'll say to set up the problem. Like I told you already, setting up the problem involved so much reading, visualization, bringing what principles to be brought. All that will happen in a small time. So that kind of a thing doesn't come easily. But supposing as you keep doing, you recognize that, yes, the first step teacher is giving, I am not doing, so let me think about the first step and let me complete the solution. Let me get my first problem. That will be my day or D-Day, whatever people call it. So that's where you transform and then start solving your problems in a big way. Thank you so much. We'll come back with another interesting idea later.